want everybody to welcome Akshay Agrawal. He's going to be talking about rapid threat modeling.
Can you guys hear me? Cool. So good morning, ladies and gentlemen. I'm actually quite curious myself as to what Phil Zimmermann has to say down the hall. And I was hoping that my talk wasn't with him, but it is. And I appreciate the fact that all of you chose to attend mine. My name is Akshay Agrawal. I work as a computer security consultant with IOActive, and we're going to be discussing rapid threat modeling today. I'm going to be focusing the first part of my talk on what threat modeling really is. Can I see a show of hands of people who've actually ever had to do a threat model? That's... And can I see a show of hands of people who have had problems doing threat models? So I'm actually talking for you guys. And so I'm going to be talking about threat models, giving you the objectives of threat models, what our suggested process is, giving you the concepts of rapid threat modeling, giving you a couple of definitions, showing how we can use documentation that we gather during the software development lifecycle. And the second half of the talk, which is going to be the interesting half of the talk, is going to be a case study in which we're actually going to use these concepts. So what is threat modeling? Threat models basically allow you to systematically identify systemic threats. That's almost as difficult to say as it is to understand. So what that really means is a threat model tries to map out what your business risks and threats are. Business threats are basically derived from business goals. Without business goals, there are no threats against your business. And a threat model really tries to give you a holistic view of the security of a system. Can you still hear me? So what are the objectives of rapid threat modeling? It's the number one objective really is to identify architectural and design flaws. It's been said repeatedly that identifying architecture and design flaws saves the most amount of money for any application team or any product being developed. And just because it's been said a lot doesn't mean it's not true anymore. It's still true. The second thing the threat model really does for you is it helps you understand and prioritize risk. Like any risk management technique, it's critical for us to understand and prioritize risk and to optimize resource allocations in order to minimize that risk. And threat modeling is a great tool to do that. It also helps us evaluate changes to systems in terms of feature additions and in terms of changes to the requirements for a particular application. And the thing that I personally like the most about threat models is that it helps from the perspective of an attacker, which is generally what I am. It helps us mount complex multi-stage attacks, envisage them, and conceptually mount them. One of the key aspects of a threat model, as we would like it to be, is repeatable. For it to be repeatable, verifiable, and consistent. I mean, this is absolutely key for any model. We're going to utilize some documentation, and threat model gives you a high-level picture of what this system is and helps you identify conflicts. Again, the first four are the most important objectives. The process that we have suggested to our clients has been to start off with threat models in the initial design phase. enhance these threat models as they take technological decisions on what technologies to implement and how to implement them, and review the risks and threats and mitigation techniques with their development team before they begin implementation, so everybody's on the same page. A threat model is refined and, more importantly, verified during a security review if you have one in place. This basically helps ensure that a threat model actually represents the system as it is. And this process is repeated for all versions. So the basic crux really is that the threat model is a living document. It's never done. So what is rapid threat modeling? Rapid threat modeling basically consists of three things. It consists of the ability to identify requirements and therefore threats in an unambiguous manner from documentation that you already have. It also involves automation of the threat generation process and the attack tree generation process. This is something that, due to paucity of time, I'm not going to go into a lot. And also attack libraries. Attack libraries are basically just information that you pre-gather and put into attack trees based on scenarios which have been previously identified and are pretty standard. There's really not much to talk about attack libraries, so I'm not going to. So some definitions to understand this talk better. We're going to be using a subject-object matrix. A subject as defined for us in this situation is a subject is an actor, usually a human, and in some particular cases it can be a process interacting with the system. The object is an asset that is in the business rules. This is a very carefully worded definition of an object, and if someone asks me a question on that, I will answer it later. An action is something that is done by the subject on the object. A rule are the conditions governing a valid action, and I'll come to an example of rules later. A threat is an inversion of any of these rules. So whenever a rule gets inverted, and there can be several inversions for one given particular rule, that constitutes a threat for our system. Attack is basically a realization of a vulnerability, and an attack tree helps you map out an attack from the leaf nodes to the tree. A mitigation is basically why an attack was not successful, and the weakness is the reason why the attack succeeds. As defined by the attack tree, a vulnerability is an unmitigated path from the leaves of the attack tree to the threat. So basically, if any node in the middle is mitigated, then it's no longer a vulnerability. And attack libraries we've already gone into. So I'd like to reiterate, it really isn't a threat if it doesn't affect your business. The SDLC documentation that we use that is useful for gathering this information is basically the requirements documentation, which is essential. Unambiguous requirements documentation is the crux of the threat modeling process. And unambiguous requirements basically lead to unambiguous rules. And a rule can be, say, subject foo creates object bar, or subject foo creates object bar if subject foo is the owner of object bar. Updates object bar if he is the owner of object bar. We need to understand what's the data flow between these processes are, what the state of every process and every actor and every asset in the system is, and we use use cases to map out workflow and also to represent state. So the second part of this talk is basically going to be a case study. The editors of an information security magazine, nofud.org, wish to rid the world of fear, uncertainty, and doubt. So they aim basically to attract top security researchers and get top-notch content for this website, maintain tight editorial control as to what is published and who publishes it, and allow readers to browse articles free of cost at all times. One of their requirements is that users should be able to comment on articles too. So from these requirements, we abstract rules for this particular application. The rules are the author can create a submitted article, the author can update his own submitted article, the editor can create, update, delete, or publish any submitted article, and so forth. Another point I want to mention at this point is for this particular application, the only allowed actions are create, read, update, and delete. The threat modeling methodology basically works for any action, but these are the crux actions that you'll usually find an actor performing on an asset. So just to give you a brief idea of the DFD for context DFD for this particular application, you have the reader, the author, and the editor talking to the system, and which has a repository and sends information back. The level 1 diagram, which is a little more detailed, again, for this particular system, we see that the author can submit articles and view submitted articles and view published articles, but can't publish articles. The editor interface allows the editor to manipulate both submitted articles and the published articles, and the reader can only perform one action, which is to read articles. Again, I talked about state earlier, and state is essential for any threat modeling process. We represent state in terms of use cases. I'm just giving a brief example of a use case as it might pertain to this application. So in this use case, the editor consumes a submitted article by reading it, creates a published article from the consumed submitted article, and deletes the submitted article to signify a state change. And this is, again, consumed by readers, authors, and editors. So now, we come to the subject-object matrix. In this subject-object matrix, as you would see, it relates to the rules that we got that we derived for the application from the requirements. The subject-object matrix has 3 subjects: the reader, the author, and the editor, and 4 assets: submitted articles, published articles, layout, and comments. And you see that every node of this matrix actually represents 4 actions: create, read, update, and delete. The color green basically says that this action is allowed. Yellow says that this action is allowed but has certain conditions attached to it, and red is a disallowed action. So how you would interpret this subject-object matrix would be that the reader cannot create, read, update, or delete submitted articles. The reader can read published articles but cannot do any other action. The author can create, read, and update and delete submitted articles, but can only do so conditionally, where the condition is the author must be the owner of those submitted articles. So it establishes a conditional relationship with the author. Again, if you look at comments, the author has an additional capability of editing his own comments, which the reader does not have. So from this, as we mentioned earlier, any rule, any inversion of any rule is a threat. So if you have the subject-object matrix, to derive the threats for this particular system is fairly trivial. So the first threat we're basically going to look at is the reader. The rule is the reader cannot create, update, or delete published articles. So the inversion of this threat would be that the reader can create, update, or delete published articles. And for this, we've generated an attack tree. The top node being the actual threat, 1.1 being the reader can elevates privilege for submitted articles. These attack trees can be pre-generated and can be automatically generated using a system that I'll very, very briefly describe in the end. Again, let's look at another threat. Another threat is the reader cannot read published articles. This is a denial of service kind of threat, and it relates to the reader can read published articles. So it's an inversion of this particular threat. The third threat that we can look at is the author creates comments as another author. Right? This is an inversion of the threat. The author can create, or of the rule that the author can create comments, but only as himself. Right? But this rule itself can have two inversions. The other inversion for this rule is the author cannot create comments. So that's a denial of service scenario against comments. So I've just drawn out a threat tree for one of those threat scenarios and not the other. But it's essential to understand that every rule can have multiple inversions and therefore multiple threats. So one of the things that I had mentioned earlier was that threat models give us a very good way of understanding the impact of a change on an application or a system. So how can we actually do that? So to illustrate how we can do that, let's make some changes to NoFUD. Basically, we are adding a subscription service for archive for subscription users, adding some ads, and we're changing the functionality that the editor has. The editor is no longer all-powerful, and the editor cannot publish his own articles. He can publish any other article but the one he wrote himself. That's a requirement change now. So as a consequence, some rules are added and some rules are changed. And let's look at what the changes are. So as we see, as this application has progressed, we've seen two new objects being added in. One is the archived articles, and the other is advertisements. We have another two subjects, the authenticated reader and the ads generator. As we see, the authenticated reader has the same capabilities as the reader himself, except for the fact that the authenticated reader can read archived articles. The ad generator can only create ads. It cannot do anything other than create ads. Also, the editor, the editor is no longer all-powerful, as I mentioned. So we see that the editor can only conditionally create published articles or conditionally create archived articles. And the condition, again, being that the editor has to own the article if he's should not own the article if he is to publish it. So again, there's been some exciting threat modeling work in terms of automation of this threat generation and attack tree generation. This methodology is called Trike by Paul Saiter, Brendan Larcom, and Michael Eddington. They will hopefully release a tool soon, and you can get their paper for this methodology at this particular website. What we basically mean by automation of threat generation is the fact that threats can basically be compiled, and we can generate other base threats on the basis of a top-level threat. For example, a denial of service attack. A denial of service attack can exist if resources are exhausted. So that is the next step. You can look at what resources there are and add those in to your threat tree to get all the threats for denial of service. Basically, the case of a reader publishing articles. The way a reader can publish articles is by elevating his privilege. So you can see what actors actually have those elevated privileges that the user needs in order to fulfill that threat. And so you can pre-generate those threats in the attack tree. And coupling this with technological choices and plugging in attack libraries, you can significantly speed up the threat modeling process. And also, one of the key components was the fact that, in our view, we saw that when using other methodologies, usually when we gave two different people the task of creating threat models for a particular application, we got threat models which were as varied as the people themselves. This methodology, the neat feature of this methodology is that it allows convergence of the threat model towards a single consistent model. So in conclusion, what we spoke about today was understanding the process of developing rapid threat models, reutilizing SDLC elements, and the need for unambiguous requirements. The subject-object matrix method for developing and visualization of threats. And basically, I spoke very briefly about the threat modeling process, automation, and attack library generation. Thank you. Absolutely.
Just more of a practical application.
So actually, that's a great question, and I actually have an answer for that. So one of the methodology also comes up with ways to first write business rules, and which I did not go into because of paucity of time. And it also has a parser which extracts business rules from requirement documentation. So we don't expect people to be unambiguous. I was just saying that is a desired concept, but I absolutely live in the real world and don't expect people to have realistic requirements.
Back to the first part of my question, again, sort of practical application. Again, your case study, pretty straightforward, very basic what the requirements are for the business rules in that application. Again, take a large implementation or some sort of application spans organization. So there's a component here, there's a component over there. Now, how do you go create a threat model for that isn't as big as this room?
Well, absolutely. A threat model really does, the more assets and the more actors you have in a threat model, the threat model does become as big as you're saying, as big as a room. The way that we approach that is by isolating application layers and isolating components, and then creating threat models for components, and then linking the threats again. So one of the things I wanted to mention about in terms of the DFDs was that you do see trust boundaries in them. So that's one of the things that we utilize to isolate threat model generation and isolate and fragment applications. And if you read the Trike paper, that has that alludes to that, but in the next version, I know for a fact that there's a huge section on that. Yeah, go ahead.
So it seems to me with the subject-object matrix, what you're modeling though is just authorization, right? You're not. I mean, for instance, if one of my developers is using a hard-coded key with some kind of custom cryptography that his kid brother wrote, how are you going to ever catch that?
So that's a really good question, because of the simple fact that comes. So what we're trying to develop, what we're trying to really bring out from this particular aspect is just getting the top level threats. That was the crux of my talk. The way that you would find that is once you have a top level threat and you plug in your technological choices, whatever you made. So you chose to have some kind of crypto mechanism, and so you plug in whatever the attack library for that particular crypto algorithm or crypto algorithms in general are, and that would have a node which would say that the key should be stored securely, and you would check that you would verify that in a security assessment that is actually correct, right? So your basic implementation details really go in your attack tree and not on the. It's not a top level threat. Right? It's not.
I guess it depends on how you define top-level threat.
So exactly, that's precisely why that's what the crux of this talk is, that if you start defining top-level threats as implementation threats, then your threat model, like the gentleman there said, would become ever unwieldy, and you would not be able to your threat model would not be consistent with anybody else's threat model, because it would depend on what your level of knowledge about threat models, or person creating the threat model, what his level of knowledge was, right? With this mechanism, you can standardize on a particular you can be sure that if you create the threat model or I create the threat model, it would look pretty much similar. And I can definitely take this offline and go over some aspects of the paper with you. Sure.
Typically, how much time would you say this type of threat modeling would add to a project if you've not been threat modeling before?
That's a good question. Most of our time is really taken in filtering out requirements into a format that we like. Like I said, we do have certain automated tools that will generate a huge portion of this of the attack trees for us. That those haven't been released yet, but they will be released. This is so. I would say for in real world examples, for a large for a medium size online retail store which employs around 200 people and has say, $200 million worth of business, it would take us somewhere on the for the entire organization. It would take us somewhere on to the order of 10 working days to create one. That being with a lot of manual work involved as our methodology was being developed. Thank you.